Teleportation. In movies, it's the ultimate fantasy. Freedom, danger, illusion. But what if it wasn't just fiction? In Jumper, teleportation means living without limits. In The Fly, one mistake turns it into horror. And in The Prestige, it blurs the line between magic and science. 3 stories. 1 question: could teleportation ever be real? Today, scientists are already experimenting with quantum teleportation. Not moving people, but moving information across impossible distances. The first step toward something we thought only belonged to fiction. Imagine instant travel across the world, or instant communication across the universe. What would it mean for power, for identity, for humanity itself, if teleportation became possible? From fiction to frontier science, this is the story of teleportation.
Right here, right now.
Before science, we dream through stories. And few dreams are bigger than teleportation. In Jumper, teleportation is pure freedom. No planes, no borders, no limits. Imagine being able to escape danger, or steal anything you want, with a blink. It's the ultimate power fantasy. But every fantasy hides a cost. Movies like Jumper show us the thrill, but they also reveal the fear. What happens if such power exists in the real world? Who controls it? Who stops it? And is freedom without limits really freedom? Then there's The Fly, a story not about freedom, but about failure. A brilliant scientist tries to bend reality, but one tiny error corrupts everything. The result isn't triumph, it's horror. Teleportation here isn't escape, it's mutation. A reminder that moving matter is more than moving bodies. It means rewriting life itself. And one wrong line of code could rewrite you into something unrecognizable. And then comes The Prestige. At first, teleportation is just a magician's trick. But when technology enters, the illusion becomes something darker. It isn't teleportation at all. It's duplication. A copy. Perfect in every way. Except it isn't you. The film asks a question more unsettling than any machine. If a perfect copy of you appears on the other side, is that still you? Or are you gone the moment the machine turns on? From freedom, to mutation, to questions of identity, fiction gives us 3 visions of teleportation. But science tells a stranger story. Because in labs today, something called quantum teleportation is already real. Not the teleportation of bodies, but of information itself. We've left fiction behind. Now we step into the lab, where scientists don't teleport people, but something even stranger, the information inside particles. This is quantum teleportation. Quantum teleportation was first proposed in 1993 by Charles Bennett and his team. Their protocol showed how the state of a quantum particle could be transferred from point A to point B, without the particle itself traveling the distance. In 1997, physicists at the University of Innsbruck made it real. They teleported the polarization of one photon onto another far away, using a mix of entanglement, a Bell state measurement, and classical communication. It wasn't science fiction. It was the first proof that teleportation was possible in the quantum world. After Innsbruck, the race was on. In 2012, scientists in the Canary Islands teleported photons across nearly 90 miles of free space between La Palma and Tenerife. It required ultra-sensitive detectors, precise timing, and active stabilization to keep the beam alive in open air. Then in 2017, China shattered records with the Quest satellite, nicknamed Misuse. They teleported photon states from a ground station in Tibet to the satellite in orbit, over distances up to 1,400 kilometers. The fidelity averaged around 80%, well above the classical limit. Teleportation had officially reached space. So how does it work? 3 key ingredients: entanglement, a Bell measurement, and a classical channel. Entanglement links 2 particles so tightly that what happens to one is reflected in the other. The Bell measurement collapses the original state, and the classical signal tells the receiver how to rebuild it. The catch: decoherence. Environmental noise, air turbulence, fiber loss, background light, destroys entanglement quickly. Efficiency drops. In the Misuse experiment, millions of photons were created, but only a tiny fraction survived the trip to orbit. Still, even a few successful events were enough to prove teleportation works on a global scale. Let's talk numbers. Innsbruck, 1997. The first lab-scale teleportation. Canary Islands, 2012. Photons teleported across 143 kilometers of free space, fidelity beyond the classical limit of 2/3. Then Misuse in 2017, ground-to-satellite teleportation up to 1,400 kilometers, with average fidelity of 0.80. The team had to run the experiment at night to minimize atmospheric interference. Out of millions of photons, only a handful made it, but they proved it could be done. And in fiber optics, teleportation has been demonstrated across kilometers of cable, even converting photons between wavelengths, like 1,300 nanometers to 1,550 nanometers. Every experiment adds distance, fidelity, and new techniques for quantum communication. So what does this all mean for us? First, unbreakable security. Quantum teleportation enables quantum key distribution, QKD. Any attempt to intercept the signal collapses the state, alerting both sides instantly. The foundation of a quantum internet. Second, global communication. Satellites like Misuse are just the beginning. In the future, we could see worldwide quantum networks, linking continents with secure, entangled connections. Third, technology spin-offs. Ultra-sensitive detectors, better fibers, error correction for qubits. These tools push us closer to teleporting more complex quantum states, maybe even atoms one day. But people, that's still fantasy. The no-cloning theorem forbids copying unknown quantum states. And teleporting a human body atom by atom would require impossible energy and unimaginable data storage. So for now, teleportation means quantum communication, not instant travel. A powerful tool for the Internet of the future, but not yet the machine from science fiction. Science has pushed teleportation into orbit. But the hardest questions remain, about bodies, minds, and identity. In the lab, we teleport states. In fiction, we teleport selves. And next, we'll confront the risks, what teleportation might cost us. In David Cronenberg's The Fly, a scientist builds a teleportation machine. But something goes wrong. A housefly slips in during the process. The result: a grotesque hybrid of man and insect. Fiction, yes, but it taps into a primal fear. What if teleportation doesn't just move us, but changes us? Teleporting a human isn't just about moving atoms. It's about recording and transmitting every quantum state of 10^28 particles in the body. That's more information than all the data on the internet by orders of magnitude. The bandwidth required to send that data, even at the speed of light, would take longer than the age of the universe with today's technology. In fiction, the machine solves this instantly. In reality, the information problem alone makes human teleportation practically impossible. But even if we could capture all that data, another nightmare emerges: the copy problem. In order to teleport you, the machine must destroy the original and rebuild you elsewhere. But what if it doesn't? Then you've created a duplicate, two versions of you, each believing they are the original. This isn't just science fiction. It's a real philosophical and ethical puzzle. Teleportation, as described by physics, doesn't move matter. It reconstructs states, meaning the you that arrives may not be the same consciousness that left. It may be an identical copy, with the original quietly erased. Back to the fly. While human-insect hybrids are fictional, the underlying fear is real: errors in transmission. Quantum teleportation is not perfect, it relies on fragile entanglement. Even in the best labs, fidelity rarely reaches 90 to 95%. For photons, that's fine. For DNA, a single bit flip could mean cancer, mutation, or neurological collapse. In principle, error correction could reduce risk. But the scale, billions of bases of DNA, trillions of neural connections, makes flawless reassembly nearly impossible. Teleportation errors aren't about creating a monster. They're about subtle, deadly misprints that destroy identity at the molecular level. Teleportation, if it were ever real, wouldn't just be risky biologically, it would be a security nightmare. To teleport, you must scan and transmit every detail of a body or object. That's raw, unfiltered data: DNA, brain structure, memories. If intercepted, it becomes the ultimate weapon: the ability to clone, manipulate, or erase identities. Imagine military use, teleporting warheads, or even teleporting enemy leaders against their will. Or worse, altering the blueprint mid-transmission. Science fiction. Sure. But in principle, teleportation tech would be as dangerous as nuclear power, maybe more. Finally, there's the question of you. Even if teleportation were safe, even if it worked flawlessly, would you step inside? Would you trust a machine that destroys your body and reassembles you somewhere else? Philosophers like Derek Parfit have debated this for decades. If your body is destroyed, and an exact copy is rebuilt, is that still you? Or is it someone else who merely believes they're you? Teleportation, at its core, forces us to face the fragility of identity. Teleportation may never carry our bodies across space, but the risks, informational, biological, ethical, show why science fiction is more than entertainment. It's a rehearsal for the dilemmas we'll face as physics advances. From monsters in movies to photons in orbit, the line between fantasy and science is thinner than we think. The question is, are we ready to cross it? In Jumper, teleportation isn't about science, it's about freedom. Blink, and you're anywhere. But what if teleportation didn't move your body at all? What if it moved something deeper? Not flesh, not blood, but consciousness itself. What if one day, science could teleport your mind? Traditional teleportation dreams focus on atoms, molecules, matter. But neuroscience suggests identity isn't locked in matter, it's in patterns. Billions of neurons firing in sequences. Roughly 86 billion neurons, with 100 trillion synaptic connections. If those connections could be mapped, copied, and transmitted, then in principle your consciousness could travel without your body. Not teleportation of matter, but teleportation of mind. Projects like the Human Connectome Project and advanced fMRI scans are slowly mapping the brain's wiring. Researchers at MIT have already simulated small networks of neurons digitally. Japan's K supercomputer once modeled 1% of the human brain for a single second, and it took 40 minutes of compute time. These numbers highlight the scale. Uploading or teleporting consciousness would require computational power far beyond today's capabilities. But the trend is clear. Every decade, we move closer to decoding the brain as an information system. Some scientists, like Roger Penrose and Stuart Hameroff, have even proposed that consciousness may have quantum roots, that microtubules in neurons could exploit quantum effects. If that's true, then teleporting consciousness wouldn't just mean copying neural patterns, it would require quantum teleportation of mental states. So far, this theory remains controversial, but it connects directly to today's quantum teleportation experiments, where photons, and even small molecules, are already being moved through entanglement. Teleporting consciousness overlaps with another speculative frontier, digital immortality. Imagine scanning your mind, uploading it into a digital substrate, and transmitting it across the planet, or even to Mars. Companies and labs, from Neuralink to Blue Brain Project, are taking early steps toward brain-machine integration. If such technologies mature, teleportation won't be about moving bodies through space, it'll be about moving selves through data, crossing not just distance, but death itself. But here lies the paradox. If your consciousness is copied and sent elsewhere, are you still the one who wakes up? Or is it just a digital clone, while the original you fades away? Teleporting consciousness raises the same identity puzzles as physical teleportation. Is continuity of experience required, or is pattern enough? If a perfect copy lives on Mars, but you die on Earth, did you actually teleport, or did you just end? From Jumper's fantasy of limitless freedom to real neuroscience and quantum experiments, the idea of teleporting consciousness forces us to rethink what it means to travel, to survive, even to exist. Teleportation may never deliver the body, but perhaps, one day, it will deliver the mind. The question is, would you trust your future to a machine? From freedom in Jumper, to horror in The Fly, to the identity puzzles in The Prestige, teleportation has always been more than just moving bodies. It's about the limits of physics, the fragility of biology, and the mystery of identity. Science tells us teleporting matter is nearly impossible. But teleporting information? That's already happening in quantum labs. And the idea of teleporting consciousness, of sending the mind without the body, may be closer to our future than we realize. So the question remains, if the machine existed today, would you step inside? If you want more explorations like this, where science collides with imagination, hit subscribe, drop a comment with your own what if, and share this video with someone who loves big questions. Because the future doesn't just happen, it's imagined first.